Today we're going to start with solving equations by factoring. We're going to begin with factoring binomials. A binomial has two terms, so x plus 6 could be a binomial, or 2x plus 3. Factoring a binomial, we're going to be rearranging them by moving out a common factor. The factor can be either a variable or a number, or a combination of the two if they're multiplied together. And factoring is just the opposite of expanding or distributing. Here we have an example of expanding distributing the 3 to the x plus 2. So we get 3 times x plus 3 times 2, resulting in 3x plus 6. Factoring is taking the last part, the 3x plus 6, and splitting that up. We take a common factor out of 3, so we're left with 3 times x plus 2. Here are some problems for you to try. In the first, we pull out a common factor of 5, and we're left with x plus 1 as our remainder. The second one, we pull out a common factor of y, so we have y times 14y plus 3. And in the third one, we pull out a common factor of 4x, so we're left with 4x times the quantity x minus 6. You can also factor using this theorem, the difference of perfect squares. For every a squared plus minus b squared, when you factor that, you get a minus b times a plus b. So there's an example. X squared minus 4 will give you, your a value will be x and your b value will be 2. So you get x minus 2 times x plus 2. And underneath that we have another one, 4x squared minus 25. So your a value will be 2x, because when you square that you will get 4x squared, and your b value will be 5. So for your first quantity you get 2x minus 5, and for your second quantity you get 2x plus 5. You can use factoring to solve quadratic equations. A quadratic polynomial is in the form ax squared plus bx plus c. To solve that, you're going to look for two numbers that multiply to be the c value, and the add to be the b, the coefficient of the x to the first term. So the steps to factoring, you're going to identify your a, b, and c values first in your quadratic polynomial. A is in front of the x squared term, b is in front of the x to the first term, and c does not have an x attached to it. Then you are going to write down the factor pairs that multiply together to be c. Select the term or the pair that will add to be b. Substitute the factor pairs into two different binomials, and you will have your factoring done. Here's an example. Factor x squared minus 11x plus 18. Your a value will be 1, because there's a 1 times x squared will give you x squared still. B will be negative 11, because we have a minus 11 in front of the x to the first term, and c will be 18 because there's no x attached to that. That's your constant term. The factors of 18 are 1 times 18, negative 1 times negative 18, 2 times 9, negative 2 times negative 9, and 3 times 6, or negative 3 times negative 6. Here we have the factor pairs listed, and then also a column of the sum of the two factors that we had. So 1 times 18 will give you 18, and when you add 1 plus 18 you get 19. We're looking for negative 11 here, so that's not our pair. Negative 1 times negative 18 also gives you 18. When you add those together you get negative 19. 2 times 9 is also a factor. That will give you 11. Negative 2 times negative 9 will give you negative 11 when you add the 2, and that's the one we're looking for. So our final answer is x squared minus 11x plus 18 factored is the quantity x minus 2 times the quantity x minus 9. We can also solve quadratic equations by factoring. In this case, we're looking for the zeros of the graph. These would be when y equals 0, so they are on the x-axis, also called x-intercepts. To solve this, you want your quadratic formula or your quadratic equation to be set to 0, so you have your ax squared plus bx plus c equals 0. Then you're going to factor and use the zero product property to solve. The zero product property states if a times b equals 0, then a equals 0 or b equals 0. So if x minus 2 times x minus 3 equals 0, then x minus 2 equals 0 or x minus 3 equals 0. And then you solve for each case. So x minus 2 equals 0, you would add 2 to both sides, and you're left with x equals 2. Or you have x minus 3 equals 0. You add 3 to both sides, and you get x equals 3 as your answer. So there should be a point at each of those spots on the graph where the graph will cross the x-axis. To factor a polynomial that's greater than the degree of 2, so it's got more than x squared in it, you will pull out any common factors that they have. Usually they have a variable in common. And then you will factor the simplified polynomial left in the parentheses. So here's an example of that. We have 10x to the fourth plus 15x cubed minus 45x squared. And we pull out a common factor of 5x squared. We're left with 2x squared plus 3x minus 9 in the parentheses. And then we can factor the parentheses, and we get 5x squared times 2x minus 3 times x plus 3. Here's one for you to try. 30x cubed minus 120x. So we can pull out a common factor of 30x. And we're left with x squared minus 4, which we can now use our difference of perfect squares. So we have 30x times x minus 2 times x plus 2 as our final answer. And here's one more for you to try. Factor and solve for the x-intercepts. X squared minus x plus 6 equals 0. So we're going to factor that first, and we get x minus 3 times x plus 2 equals 0. And then using the zero product property, we know that x minus 3 equals 0 or x plus 2 equals 0. And our final answer is x equals 3 or x equals negative 2.